Stuart Walsh, the product director at Creativity Software, and we are all things location technology based. I'm going to introduce you to some of the challenging concepts of overcoming 3D positioning, especially in large, dense urban areas, and what are the pathways forward. So the whole idea is, if I can get it to the next slide, he says. Got it. So I'm just going to go through this, where I'm going to talk about where the technology is today, why do we need 3D technology, and then what are the strengths, weaknesses, and the pathway forward. Very quickly, I'm not going to spend too much time on this, but emergency location today is quite well established from a 2D perspective. We got a lat long, and we can pinpoint precisely where they are. This is near our office. We're based in London, in a beautiful district of London called Kingston. And this is the kind of thing that a lot of you will be familiar with, where emergency services are given a lat-long position of where that emergency caller might be. Where do you dispatch the technology? And it's quite well established, but one of the challenges, even with that still, is not yet universally deployed as technology, offering emergency services very high reliability, very high accuracy. And when it comes to 3D, that's going to be a new challenge. The big thing is, originally we had lat long, the X and Y, but now we're going to introduce the vertical part. And that vertical part is the X-axis, and really specific here. This is no specific city, but when we make an emergency call and the emergency caller is high in the building, and then when an emergency responder comes, it would be very powerful and even capable of saving lives if they know what floor they have to get to and what entrance they got to get to. You must have encountered this in your daily lives out there. Even my own father, who was a paramedic and emergency responder, used to tell me about the stories of he would arrive at a large, tall building and no one in the front desk would know who's the person in distress because they made a call from the 15th floor. And it's the requirement to be able to locate in a building, as an example. It could also be underground, it could be in a stadium. Think about all the scenarios when you go 3D. You also need to increase the accuracy. That's really important. It's required to be able to position the caller in the particular building. It's fine that you could say that they're on the, say, 14th floor, but there might be 16 offices on that 14th floor. So increased accuracy is required. And which we'll talk about today, 3D maps and 3D map sources is critical to the success of this capability. So a little bit why, obviously, hopefully this is really obvious. Why provide 3D location? The whole idea is that finding an emergency caller in a tall or complex building represents a challenge. If you've ever been out there either running emergency services or actually being a responder, arriving to a building such as this gentleman here and being told, what floor is the person on, if they could be prepared, that would be key. Time to find the caller is critical to saving lives. And preparing an emergency service responder so they know which entrance to take and to be prepared, because if they have to go straight up to the building but then they've forgotten something and have to go back down, preparation is key because you prepare to succeed. And that's really key in this process. So 3D location techniques, I'm going to talk about this a little bit. What I've got to say is that we're just starting to venture on this journey. I'm proud our company, Creativity Software, is involved in helping define AML with BT and our colleagues here on the stage from Google and others. And we think it's been one of those great success stories. But now we've got to start the journey with 3D vertical indoor. I'm going to kind of introduce you to two approaches that we're going to talk about. But these are just some of the approaches. I think this will evolve and change over time. But they'll be from the handset perspective. What can the handset see when it's indoors or high up or in a tube station or down underground? And then the second one is, what can the network itself see? What can it actually build from information-wise? Those are the two perspectives I'm going to talk about. Any combination of these approaches can be utilized, and I strongly believe that it needs to be a combination. We, as creativity, we strongly believe, and we try to prophesize this around the world, that you need to use multiple techniques to get you the highest level of accuracy and reliability. You don't want it to be 50%, you want it to be close to 100%. So, whatever combination of techniques are used, they absolutely need to provide widely available, covering all types of handsets, feature to smartphones, the oldest 2G phone to the newest 5G phone. You've got to cover the greatest scope of your population, which is possible. And that's one of the things that's going to need to be taken into consideration with this process. It also needs to be highly reliable, and reliability is key, and 3D is going to present an enormous challenge for us to be able to do that as a kind of collective in this process. And it's something that we've got to be starting to think about now. I'm going to talk a little bit about what they've been doing in the US, where they've pioneered this, and some of the challenges that they've encountered and how they're moving that forward. In general, we're trying to get to around 3-meter vertical, roughly getting you a floor. This is always to do with the challenge, because accuracy versus reliability is key, but that would be the target. So let's start with handset technique information, and let's talk about the strengths and weaknesses. Let's start with the obvious one, GPS. I don't need to ask anyone in this audience, what kind of GPS signal do you think you'll get indoors? You will get a GPS signal indoors, yeah? But in order to get vertical where you are, you need a satellite pretty well above your head, as well as a cloud of constellations. So really that one is weak, unless there are GPS repeaters. But then they've got to be all over the country, in every building, in order for it to be kind of properly dispersed. More importantly, did you know that your phone can measure the air pressure? How many people knew that? Exactly. Didn't know this. Something Google know well, as do other handset manufacturers and operating systems. And it's quite key because it can measure the air pressure of where you are. Now, it's not on all phones, but it is on quite a widespread of phones these days, being able to use the existing technology within the phone. And that can add the next layer of information. So they can actually measure the pressure and say, I think it's at this level, above sea level. Or, in fact, if it's below sea level as well. Next one, which people would be thinking about, is Wi-Fi. In other words, Wi-Fi is in pretty well every building. It's available. The phone can see it to help derive its location. The drawbacks with Wi-Fi is to do with the reliability of that Wi-Fi source, making sure that the node is documented, that where it is, its location, and being able to access information on it is key. So there are strengths and weaknesses to that. That needs to be considered. Quite an approach that a lot of governments are starting to look at is beacons or sensors. They went this way in the US for a fair portion of what they're going to look at and going forward, placing these location beacons around very dense areas, which gives you very good reliability and accuracy. The challenge is cost and time, because imagine how many of these beacons you have to put around. It's enormous. They've found this, the richest country in the world, in the USA, they have struggled to try and map this out, but they've pioneered it, which I really compliment them, because they bit this bullet hard, and they're really moving it forward. Finally, the mobile network is one of the final elements that obviously a phone can see, and it can ingest that information. But it's about putting all of this together, and I'll talk about that a little later. None of these on their own will provide a reliable result. And that's what we're always about. In emergency services, not only have you got to be accurate, but you've got to be reliable. And we're always about driving towards 100% reliability. And none of these on their own will drive that. But when you combine them, then you start to get some very interesting and possibly very good reliability. The other aspect is network. what can the network see information about that handset, about that subscriber? Obviously, mobile networks can identify subscribers, but did you know we have the capability to, actually it didn't quite come out on that, but we can actually measure the angle of arrival and angle of departure. So we're able to identify potentially, possibly the floors, but maybe even groups of floors, which can be added to other information. This is very possible from 4G, but really with 5G, it gives us even more reliability and accuracy. So it's a really good source. And with more mobile networks putting femtocells, microcells in a lot more places, it's going to be very powerful for this. Obviously, the dedicated beacons I talked about, where they can gather information about subscribers, about devices, and being able to have that there in the process is quite powerful. And then obviously the Wi-Fi network itself. Again, this is from the network itself, and I'll talk about how getting reliable Wi-Fi information probably be one of the key pieces of information for vertical, for 3D positioning, because of the prevalence of Wi-Fi. It is a great source of information, but we've got to try and drive towards the higher reliability of this. Again, as I said, with the handset view, from the network view, none of these on their own are going to provide us the solution we need. But by combining them, we start to drive that reliability up. We can be we can be a lot more reliable, we can be a lot more accurate. Ultimately, we want to map the path forward. And the path forward really is, there's no magic bullet. And we're only just starting the journey, really. You know, we could say we're starting the journey today. But it's something that we've got to work together, all of us, all my peers on the stage here, all of you from governmental down to the ground, down to the PSAP centers, to the network providers. We've got to work together to drive, just like we did with AML, to drive a standard for this. Stage 1 location capability is something that I drive very much about. Having all that location information driven through the data centers of the PSAP to employ more about AI, use machine learning to take all those techniques and produce comprehensive high reliability data. And it's something that we're going to be kind of pushing with governments and hopefully with you guys to help and make this more standardized. We need to bring all the parties together. We need to bring the PSAPs, we need to bring the handset, the OS vendors, the network vendors, the government authorities. All of those need to be brought together, and we need to ensure wide adoption. Just like with AML, with the help of Google and with Apple, it's got a pretty good wide berth. We need to do a very similar thing when it comes to 3D. My peers and my colleagues here will talk more as the presentation goes forward. The big thing really I find with this is to look at government mandates. And whenever you say government mandates, people go, oh my God. But really we need governments to get involved in this because they need support from organizations like EENA to help drive those standards with their partners, you guys, and support possible the costs, because these things are going to cost, but they will save lives. And if we never start the journey, we'll never end. And we really need to start thinking across all the countries you represent here. We need to start representing and talking about driving the standards to do with this. We need to learn from our cousins. How many people here from the US? I've met a few of you. Hey guys, I think I've spoken with some of you. You've kind of pioneered this with the US FCC. You've seen the pitfalls, but also you've seen the successes. And what we need to do is learn what was good and what was bad. So I'm going to be spending a lot of time in our US office there to try and help drive more standardization for the rest of the world. And in particular, I really want to try and drive it here in Europe with all the learnings that we have. Finally, and it's something that my final colleague from Esri is going to talk about, the sources is one part, but for the PSAP, they need to be able to visualize the 3D source. In other words, see which floor, see some contextual local information to be able to say, the entrance to this building is here, and this is the best way to get to that floor. Yeah, use staircase X, use elevator Y. And without that, all of this won't be successful. So we need to come up with greater standardization in 3D mapping. And it's key from that perspective, because without it, I don't think this will be successful. 2D mapping has become very well established, but 3D mapping, I think, is going to be a whole other level. Finally, just a little bit about us as Creativity. We are emergency services location intelligence people. We were founded over 20 years ago, and we're a wholly owned subsidiary of SS8. Please reach out to us. We look forward to hearing more about what ideas the community has, but also we want to try and pioneer this more and more. So if you in your region and your country are interested in starting to try this and test it and try and start putting some frameworks together, please come and contact myself, contact Creativity, and I look forward to seeing what kind of questions we have. Thank you very much.
Thank you, Stuart. And we have 2 or 3 minutes available if there are any questions that people would like to ask from the floor. If you'd raise your hand and we'll arrange a microphone so you could ask those questions. Any questions for Stuart?
It's too comprehensive.
There you go. Actually, I've got one for you, Stuart. You've talked about the 3D mapping. What's your thoughts on the willingness of governments to provide some of these 3D map sources?
It varies greatly, but it is key because if you think about the structural information for buildings, that is a key source. And without government assistance and driving that, you won't successfully build a proper comprehensive 3D map to support vertical indoor positioning. Without that, that's why I said government mandate is key, because they need to get involved. They can't just throw this over the line and say, you go and take care of this. They need to drive to ensure there is a comprehensive, starting with the big urban areas. Do they have, and that this has been led in the US, where there's a huge amount of structural information available in very large cities. And a lot of cities have that, but it needs to be comprehensive, because you don't want to be in the building where you're on the 15th floor, you've placed the emergency call, but there's no map, no 3D map to be able to do it. You don't want to be that person. So it's got to be comprehensive. It has to cover a large portion of the population. And the only people to help do that is the government and the mapping and ordnance people of the country.
Very good. Well, it sounds like it's an area that we need to concentrate on and advocate for some of this to be undertaken between government and industry. So
exactly.
We'll put that on one of the action lists for EENA and our Critical Communications Association to see if we can continue to advocate for some of that. Thanks, Stuart.